Okay, today we'll be talking about exterior lights and what we change them to. Within our company, we usually like to use induction to transfer any type of exterior light. We're probably going to be using induction. Now we'll talk about what exists currently. Most exterior lights, we're talking about pole lights, cobra heads that are on top of on streets, shoe boxes that are in parking lots, and those lights are typically what are called HID. HID is high intensity discharge. Okay, and that's what HID stands for. There's really four types of HID lights that are common. The first one is low pressure sodium. Second one is high pressure sodium. Third one, metal halide. And then there's also one called mercury vapor, which is an older technology. Of those lights, the things that differentiate them, when you see a very orangish yellow light, those are low pressure sodium. If you see a yellowish light, but more kind of peachy yellow, that's the high pressure sodium. And if the light is white, that is metal halide. Or mercury vapor. Mercury vapor is an older technology, and you don't see it as often. It's typically, if you see a whitish light, it's going to be a metal halide. But mercury vapor is again an older technology. It even has a little bit of a bluish green hue to it on the mercury vapor. Okay, any one of these lights, those are all what are called HID, or high intensity discharge. We like to replace those with induction. The reason we like to use induction's been around for about 20 years, and it's very efficient. It's a lot like fluorescent technology, except that it doesn't have the cathodes, the metal prongs on the ends of the tubes, and those metal prongs are what wear out with fluorescent tubes. The reason that they wear out is because as we turn on and off the lights, the cathodes, electrons come off of the cathodes, and you turn them on and off enough times, the electrodes come off, and then the light doesn't turn on anymore. So typical fluorescent light might last 10,000, 20,000 hours. Those are kind of typical numbers. Induction is a sealed tube that doesn't have any punctures in it. Therefore, it just has these metal bands that go around it, and they actually induce the electricity into the tube using those metal bands that go around. The beauty of that is that you can turn those lights on and off as many times as you want, and there's no electrons coming off of the cathodes, therefore the lamps last. Induction lights are rated to last 100,000 hours, which is really the longest technology that we have out there. It's even longer than LED. The LEDs that we're rated to use under our programs have to be rated to last for 50,000 hours. The induction lasts 100,000 hours. The other problem with the LED light, LEDs are coming and they're getting better and better, but they're so new that they haven't even had time to be able to do a 50,000 hour test. So a lot of these lights that they're rating for 50,000 hours are actually starting to fail sooner than 50,000 hours. So the cities of San Diego actually just this year in 2011 decided to go to induction for all of their exterior lights. City of Carlsbad has already done it. They've changed all of their city street lights to induction, and City of Chula Vista has also changed their lights to induction, and they chose induction over all of the other technologies, including LED. Okay, there was not a better technology, so they chose the induction. The reasons for it, the price, but especially the longevity of those lamps. They last so long. 100,000 hours at 12 hours a night, 7 days a week, is 26 years. So typically your exterior light and induction light is going to last for 26 years, and that gives your customer the ability not to have to go up on lifts. It's very expensive to have to change lights, especially up in high environments where most of these exterior lights are. Here in San Diego, we have a special issue called dark sky. We have the famous Palomar Observatory up in our mountains, and one thing that they decided many years ago is to use more yellow light throughout the city, and in hopes of keeping the light pollution down so that the Palomar Observatory can see, basically. And they feel that especially the low pressure sodium, they're able to filter that light out because it's so yellow. It doesn't interfere with their observatory. The basic rules are in City of San Diego, facilities are supposed to use either low pressure sodium or high pressure sodium, okay, and those can be used at any wattage, any size, anytime. Any of the other lights like metal halide or fluorescent technologies can be used if they have a certain light output, a certain lumen output. If it's low enough, those can be used anytime. And then if they're above that lumen output, they can only be used up until 11 o'clock at night. And at 11 o'clock at night, they're supposed to facilities are supposed to switch those very white types of light off so the observatory can do its work from 11 o'clock on. That's the basic concept. So what you'll find, car dealerships are a good example. They use 1,000-watt metal halides, a very white type of light, so they can sell their cars. And typically on those poles, there will be 2 metal halides and then a third one, which is usually a low-pressure sodium or high-pressure sodium. And so what happens at 10 o'clock at night, usually, the car dealerships will switch off their bright metal halides and switch on the yellow low-pressure sodium lights. And that, that takes care of the city ordinance. You will see car dealerships at 1 in the morning where they've got their 1,000-watt metal halides burning, and those things will burn all night long. So there's a question about regulation and enforcement. There isn't so much enforcement, so a lot of facilities are kind of ignoring those rules within San Diego. The other now, that City of San Diego. County of San Diego is slightly different. They do not allow they allow the low pressure sodium, but not the high pressure sodium. So low pressure sodium can be used at any time, but the high pressure sodium is not allowed in the county areas. So these are some considerations. It's important that we have an idea of them, but just so that our company has worked with the dark sky. We have worked with the person who wrote the dark sky regulations. We understand the essence of them, and we've even worked at some facilities and done facilities that are in direct line of sight with the Palomar Observatory, and with very good success. So basically the assumption is that you're going to go to an induction light if in the course of writing a program for a customer, they're asking about the dark sky. Just let them know that we know those rules, and then just go ahead with it. Once the deal comes in, we're going to scour it and make sure that depending on where they are, what type of light they have, what their necessities are, we're gonna set it up in a way that's going to work, so that they're not going to get into any type of enforcement issues or problems with dark sky. Okay, but again, if it's exterior, we like to go to induction. This includes all of the basic types of lights, which is shoebox, cobra head, wall packs that are attached to the side of buildings, anything that's exterior. It also includes some of the canopy lights, like on gasoline at gas stations where they have the canopy lights. Those are considered an exterior light, and we like to go with induction in those environments. Okay, we'll get into more of the exterior lights. One exception on the exterior lights: if the current light, the current HID or incandescent light is 100 watts or less, then on those ones we actually we have a program where we're able to go to a compact fluorescent light. That's a program, but it has to be, the existing light has to be a 100-watt lamp or less. So that would be a metal halide 100-watt or 70-watt. We would convert that typically to a compact fluorescent type of fixture because of the cost, and the light output is almost equivalent to induction, because induction is a lot like fluorescent. But we like to use those. They're a little bit easier, a little bit less expensive technology, so it works a little bit better in our programs. But again, it has to be 100 watts or less. Anything that's over 100 watts typically we're going to go to induction unless there's a special need. If they need LED for some particular reason, we can do that as well. But 95% of our business is going to be induction based until the LEDs get better, and that may start happening next year or the year after. Okay, good luck.